Okay, so we are looking at identities, and we said we'll take them as examples. We've done one. We said prove the following. This was question 1A. So we can't redo that question because we had finished it. So we'll go straight to another one.
Can you just repeat, sir, the question because
Yes, I think we should just repeat it because for me, my network has started tripping, so I only ended somewhere.
Okay. So it was cos x over sec x sin x is equal to cosec x minus sin x. The proof, I start by reminding you that sec is the same as 1 over cos. Cosec is the same as 1 over sine. Tan is the same as sine over cos. And cot is the same as cos over sine. And I made a point that for most of the identities, you have to change cosec, sec, tan, and cot to sine and cos forms, especially when we have identities like the one we have now, where they are mixed. So if they are mixed, you make sure that you change the other to sine cos forms. So in this case, we pick the left-hand side. So we have cos x over sec x sin x. So you can see we have cos sec. So we need to change the sec to cos. So this will be written as cos x over 1 over cos x. This is being multiplied by sin x. But this is the same as cos x over sin x over cos x. We can change from division because this is the same as cos divided by sine over cos. Now we can change it to multiplication and it will look like cos x multiplied by cos x over sin x. So that cos times cos becomes cos squared and then sin x. But for the most important identity, which is sine squared x plus cos squared x is equal to 1, we can see that we can solve for cos in terms of sine, and it will look like 1 minus sine squared x, and then we are saying over sine x. We are able to split this into 1 over sine minus sine squared over sine. This is the same as 1 over sine is the same as cosec, and sine squared over sine is just sine. But this is what we have as the right hand side. So we have proved. And that's how we prove such identity questions. So most of the identities, they become very, very easy if you're able to change from sec, cosec, tan, cot to sine, cos. Your way could become very, very easy. Okay, another one, B. For B, we have cos theta, sec theta over tan theta is equal to cot theta. So again, we'll get the left-hand side as we prove. Cos remains cos. Sec is 1 over cos. Divided by tan, or we can leave it as tan if we want. But this one here will cancel, so we just have 1 on top over tan theta. But this is cot theta, which is our right-hand side. Proved. Any questions? No questions. Another one, 1 plus tan x over 1 minus tan x is equal to cos x plus sin x over cos x minus sin x. The left-hand side looks complicated because it has tan, which are able to change. So we'll have 1 plus, instead of saying tan, we'll say sine over cosine over 1 minus sine over cosine. The numerator is cos as a common denominator for the numerator, and so we'll have cos x plus sin x over cos x, and so we'll have cos x minus sin x. So you can see that this piece and this piece will cancel, so we remain with cos x plus sin x over cos x minus sin x, the right hand side. Proved. So you are free to raise questions. Okay, no questions. We'll bring up something that will make you ask. This was C, D, sine x over 2 is equal to plus or minus the root of 1 minus cos x over 2. David?
I'm asking for the previous screen, so I just take a screenshot. My network was, Thank you, sir. I've done it.
Okay. So the proof of this, I don't know that we say left hand side or right hand side, but we'll definitely have left hand side as a starting point. So I advise you to always use the names that you sent me when you want to join the meeting. So for this one, we have prior information that sine squared x plus cos squared x is equal to 1. Then we also know that cos A plus B is equal to cos A cos B minus sin A sin B. What does that mean? If A is equal to B, then we are going to have cos A plus A giving us cos A minus sin A sin A. But A plus A is 2A, so meaning that we'll have cos 2A, so say left hand side, we'll have cos 2A is equal to cos squared A minus sin squared A. And from this identity, since we have sine there, we need to change this cos to sine so that we have 1 minus sine squared A minus sine squared A, giving us 1 minus 2 sine squared A. But this is the same as cos 2A. If you bring this the other side, and this guy the other side, you notice that we're going to have 2 sine squared A being equal to 1 minus cos 2A. Then we solve for sine, so we divide by 2. We divide by 2, we will get sine squared A is equal to 1 minus cos 2A over 2. If we square root, because we're looking for sine, we're going to have sine A is equal to plus or minus the square root of 1 minus cos 2A over 2. At this point, we let x be equal to 2A so that A will be equal to x over 2. And substitute where it is A, we will have x over 2 plus or minus, where there is 2A, we have x, everything divided by 2. And this is the proof. Any question?
Sir,
Wonderful.
sir,
Hello.
me, I don't understand from the
Sir.
start. I'm lost. I'm lost. I don't understand from the start. Yeah.
Okay, I've picked that. Another one.
Sir.
I also
Yes,
don't
sir.
understand
So,
anything.
Okay. Another one.
yes, yes, sir. So we're using
Sir, why do we
yes. Okay, go ahead. Go ahead. Then I'll ask next.
sir, why do we square the sign instead of a letter?
No, the sign is the holding function. Theta is just an angle in sine.
I
It's
asked.
like, okay, just a minute. It's like you have f of x squared. This means that if f of x is equal to 1 plus x, you won't just square x. You square the whole 1 plus x. That's why I don't just square the letter.
All right.
Yeah. Another one.
We've used the quite a different approach in answering this question. So is it that we're remembering that it's coming from the half angle formulas, half angle identity? I mean, so that's when we
No,
had
this
to
is
list
the
those were the basic ones.
because the identity itself is a half angle identity. And half
Okay, so we have
angles
to put
come
in
from
things.
double angle.
Okay, sir.
So you have to go back to double and then make it half.
Okay, sir.
Now let me
Now,
attempt.
sir, this one, can we prove it from the right hand side?
No.
Why?
Because if you attempt that answer, you square it. That's the first thing to do. You square it. And then if you square it, it will be hard for you to introduce this part here. It's very crucial.
All right.
And it looks like we are not started from any side. They just all appeared at once. Boom. And we have the identities. There's no side that you have picked. Saying left hand side is just a mere thing. Right?
Yes, sir. It's what I noticed as well. And
Okay, let me attend to those who are lost from the beginning. So when you see a half angle identity, we have two of them. No, we have 6 of them. There's for tan, there's for cos, there's for sec, there's for cosec, there's for cos. The first thing that you do is to remember this identity here. That's our first thing to do. Once you recall this identity, then in this very identity, since we have the half angle of sine, we change cos squared. Now cos squared is related to sine squared using this identity here. There's a direct relationship. That's the reason why we call this identity as the most important identity, because it appears in almost every identity. So having this identity, we solve for cos squared in terms of sine so that we are able to get to this half angle of sine. So we have replaced cos squared with 1 minus sine squared that arises from this identity. And then you add the common things to get to 2 sine squared. Your task from this stage is to solve for sine. So you make sine the subject of the formula. That's why we have to take everything the other side and remain with only sine squared a. Once you have sine squared, you square root because you're looking for sine. Until you get sine alone, is equal to any square root carries a plus or minus. That's why you have a plus or minus the square root of the inside. Now to move to our identity, where there is 2a, we have assumed that it is equal to x. You just assume n letter. But since here they have used x, we assume that 2a is equal to x. And then from there, you solve for a, because we also have a piece which has a. So you solve for a, you divide 2, you notice that a will come out as x over 2. And then you substitute, where there is a, you substitute x over 2. Where there is 2a, you substitute x. And you have the identity. So I give you a task. You must send this my inbox. So as you send this, I will respond by giving you the test marks. If you don't send, no response. Plus or minus the root of 1 plus cos x over 2. The hint is that instead of changing cos, you change sign. So you change sign. Remember, sign is going to come out as 1 minus cos squared a. And then there's a minus, so you have brackets to cover that as you substituted here, and then you expand the minus. It will make 1 negative and cos positive. And then solve for the cos, not the cos 2a, but solve for cos. So make cos the subject of the formula, and then you reach this stage, and then you have your solution. So you take your time when you're doing that, not now, after class. Today we have a busy
It's everyone, sir.
session. Yeah, it's everyone. Those who already received their results, I'll just respond for the question. But those who haven't, you'll be expecting to receive your results for the assessment that we wrote. And sorry for the delay. It came at a time when we had to vote for ban. So we are busy campaigning that moment. Okay, so let's move to another example. This was D. Let's bring in E.
The previous screen, sir. Just screenshot the question. Thank you.
Okay. So E, we have tan squared x minus cot squared x is equal to sec squared x minus cosec squared x. Proof. We'll pick the left hand side, which is tan squared x minus cot squared x. Change tan and cot to sine and cosine. Tan is sine over cosine. So when tan is squared, you also square sine and cosine. Minus cot is cosine over sine. From there, get the common denominator, cosine squared x and sine squared x. And then we'll have sine x, sine squared x and cosine, and sine squared x. So when you divide cos in cos multiplied by sine, we'll get sine squared minus cos squared and then another cos squared arising from dividing. Then from there, where there is, so one of these signs, we'll change it to cos. Change it to cos minus cos squared x. One of the cos change to sine. And then fix the denominator as it is cos squared x sine squared x. The question, David.
Yes, sir. Before I'm completely out of the equations, on the division part there, on the when you found the common denominator. Now, since yes, sir. So we're doing cos squared x into cos squared x times sine squared x.
Yes.
Now, when you do cos squared x into, so it is entering in there.
Look, you have cos squared sine squared divided by cos squared. So the cos squared will cancel.
Oh, okay, sir.
All right. And then you expand now, so we'll have sine squared x minus sine squared x cos squared x minus cos squared x plus, because of the minus, plus sine squared x cos squared x. Everything over cos squared x sine squared x. But you notice that this guy here and this one will cancel. The question, Sepiso.
So where have you taken the ones?
We have multiplied by, so here we did multiply this by 1. The same here, cos by 1, so we got cos.
Oh, thank you.
Okay. So we now have only two things remaining in the numerator. So we'll write them by separating the denominator. By separating them, we give each the full denominator minus cos squared x over cos squared x sine squared x. But here we'll have this guy and this guy cancelling, cos and cos cancelling, and then we remain with 1 over cos squared x minus 1 over sine squared x. 1 over cos squared is the same as sec squared x. 1 over sine squared is the same as cosec squared x. And this is our right hand side. Proved. So you can see that Once you change tan and cot, sec and cosec to sine and cos, there's no more thinking. You just keep going down, keep simplifying until you get the other side. Or there's less thinking, so that you don't over-relax. Okay, example 2. Solve for x, where x lies from 0 less or equal to x less or equal to 2 pi. 1, 2 cos 3x is equal to 1. Solution. Question is 2 cos 3x is equal to 1. The first thing is you divide by 2. You divide by 2. So we get cos 3x is equal to 1 over 2. Simple. We let a be equal to 3x. And then deal with cos a is equal to half. Which value of a gives us half when you are dealing with cos? In the first quadrant, of course.
60.
You get that a is equal to what? 60. Okay. So we have a is equal to 60. Which other value of a? Let's go to where cos is positive in the fourth quadrant. How do you obtain an angle in the fourth quadrant? It's obtained as the reference angle, isn't it?
Yes.
So 360 minus 60, we have a is equal to 300. So don't forget the quadrants. Remember in the quadrants, we are saying, hello.
How did you find the statistics?
Okay, so the 60, these are special angles. First thing. Second is that we had a table where we obtained 0, 30, 45, 60, 90. Then we also had special triangles where we found what cos 30, cos 45, cos 60. So all these questions that you'll be given on equations, most of them will be based on the special angles. So the first thing that you do is that you obtain the angle from the first quadrant. That gives you, so which angle should sit here from the special angles for us to have half? It is 60. because cos 60 is equal to half from the special angles. And once you find 60, if half is positive as it is, you go in the other quadrant where cos is positive and look for a reference angle. That's 60. So find 300. Remember, we said here they will be equal, but in this quadrant, you will need 180 minus x. In this quadrant, it will be x minus 180. In this quadrant, it will be 360 minus x. And cos is positive in the first and fourth quadrant. So these are values of A, meaning that since we're looking for x, we'll have the first one as 3x is equal to 60, divide by 3, divide by 3, x is equal to 20. Second, 3x is equal to 300, divide by 3, divide by 3, x is equal to 100. From that, if you look at the interval given from 0 to 360, it's possible that there are coterminal angles to these two angles, 60 and 300, that when divided by 3, will still be within 0 and 360. So let's look for coterminal angles. The first one is the coterminal angle of 60, that is 360 plus 60. Since a coterminal angle is the angle sharing the same starting point, which this is 60, so we have another angle starting from here that goes round and end there. That is 360 plus 60. So we have 360 plus 60, giving us 420. So A can be equal to 420, and when we equate it here, divide by 3, divide by 3, we get x is equal to 3 into 42. It goes how many times?
140.
140. Okay, so you can see that it's possible that maybe if we went round again on the 60, we could be within 0 to 360. So let's try. We start from here, get there again. That is 420 plus 360. This will be 0, 8, 780. So let's see if A is 780 and we equate it 3x to 780, divide by 3, divide by 3. We'll get x is equal to 260 within the given range. But if you try now, if we add the 360, we may be beyond, because we'll get something like 1,200 plus. So dividing by 3 will get 4 something. So we are done with the reference, the coterminal of 60. So let's try the coterminal of 300. Because 300 is here up to here. So we run from there, get here, come back, get here. Meaning we have 300 plus 360. So 300 plus 360. So get 0, 6, 6. So I'm saying A is equal to 660. So 3x is equal to 660 divided by 3 divided by 3. So we get x is equal to 220. X is equal to 220. 220 degrees. Now, so it looks like if we add another 360, we'll go to 9. Let's try 660 plus 360. So 660 plus 360. We have 0, 2 carry 1, 9, 10. And then we divide it by 3. We'll have 3 and then 4. 340. So we have another value of x, 340. Still within the required interval. So these are solutions, except they must be in radians. So we come back and do a conversion. So we multiply this guy by pi over 180. So we get x is equal to pi over 9. We multiply by pi over 180. We'll get x is equal to 5 pi over 9. We multiply by pi over 180. We'll get x is equal to 7 pi over 9. We multiply by pi over 180. We'll get x is equal to 13 pi over 9. We multiply by pi over 180. We'll get x is equal to 11 pi over 9. We do the same here. We'll get x is equal to 17 pi over 9. So these are solutions. 1, 2, 3, 4, 5, 6 solutions.
So we're supposed to write all of them in the exam.
Yes.
All this, how many marks?
Now, if you expand it like this, you at least you are assured of having a mark per angle. So the working may carry nothing, but the solutions may carry 1, 1, 1, 1, 1, 1, 1. So that 1, 2, 3, 4, 5, 6 marks. And important pieces there, you get 8 marks, yes?
So you have to account for every angle that is within the interval. You have to make sure
Within
that
the interval given.
Oh, okay, sir.
You make sure.
Okay, sir.
Okay. Another question? So whatever we end today, that's the end of this topic. I'm emphasizing. Now, next class we'll finish logs and explanation. So you don't have to miss. Three cosec squared x is equal to 4. Solution within the same interval. So you say cosec squared x is equal to 4 over 3. You divide 3 throughout, then get the square root, get the square root. So we have cosec x is equal to plus or minus 2 over root 3. This is cosec, but you know that cosec is 1 over sine. So this is plus or minus 2 over root 3. If you cross multiply, you get that sine x is equal to plus or minus root 3 over 2. So let's start with the first quadrant. Which angle gives us the positive root 3 over 2 for sine? X is what?
60.
So x is 60. So we have found one. What about in the second quadrant where sine is also positive?
Wait, before you. This is 1 over sine 8. Where does the 1 go?
So we have solved for sine. You cross multiply and divide. Or I switch here. I take this up and take the 1 down. Take this up and take the 2 down. This is matrix, so it should be the same. Are we okay?
Yes, sir. Yes.
Okay. So for the positive one, in the first quadrant, we get 60. In the second quadrant, we get 180 minus 60, which is what?
120.
120. Now, this guy is also negative. So sine is negative in the third and fourth quadrant. So what is of in the third quadrant? The same 60. So this time around, we are adding it. 180 plus 60.
240.
In the fourth quadrant, we are subtracting it. 360 minus 60, 300. For this one, you don't go around for coterminal angles because it's
Now, sir,
direct x.
on the third quadrant, why are you adding instead of x minus 180?
So what we have is the x. So here it was 180 minus x. Minus 60. Here, I explain from this concept. Here, you have, so if it was this question, we are saying we are having the theta in our hands. Okay, and not x, per se. So, let me put it this way. So we have theta, which is equal to x. So if you're in this quadrant, if you have x, you're looking for theta. Yes, so I have x, I'm looking for theta. So it will mean, it's hard to explain. Okay, let me come back. I do this. So if you have a reference angle, remember reference angle is supposed to be between 0 and 90. So if the angle I'm having is between 0 and 90, it means that we have theta. We're looking for x. So it means in this case, our x will be equal to 180 minus theta. Our x here will be equal to theta plus 180. Our x here will be equal to 360 minus theta. I don't know if you pick that. So if the angle you're having is between 0 and 90, it is the reference angle. You are looking for an angle whose reference is what you have. So in our case, the reference angle is 60. We are looking for the angles whose reference is 60. So in the second quadrant, it will be 180 minus the reference that we have, which is 60. We get 120. In the third quadrant, since we have 60, which is our theta, to get x, we must add 180. And so we added 180 to get 240. And then in the other one, we still subtract, so we get 300. Hello?
So you only have to find. So you only have to find for the 4 quadrants. That's what's important.
So we have found for the 4 quadrants because the question has sin x is equal to root 3 over 2, or sin x is equal to negative root 3 over 2. So for the positive, we know sine is positive in 2 quadrants. For the negative, sine is negative in 2 quadrants. That's why we have 4 solutions. We don't go for coterminal because what we have is a direct x. It's not being multiplied by anything. So there's no possibility of going beyond. If you look for any coterminal, it will be beyond the given interval, because we're looking for the interval 0 to 2 pi. So if you look for a coterminal angle of n of these, that angle will be beyond 2 pi. And there's nothing to divide it to bring it down to 0 to 2 pi.
Sir,
Hello?
how healthy is it? The other one you are explaining for the quadrant, especially in the third quadrant. Now, instead of using that method, for me, I'd put it in this way. I said 60 minus 180. Then I got a negative 120. Then I had to find its coterminal angle. So I subtracted it from 360 and got a 240. So how healthy is it?
Okay.
Or I'm just lucky?
It works.
It works.
It works.
Oh, okay, sir.
Okay, so, but remember our question is in radians. So you convert pi over 180, you get pi over 3. Pi over 180, you get 6 there, 2 pi over 3. Pi over 180, 6 there, 4 pi over 3. and pi over 180. 6 there, 5 pi over 3. And that's how you obtain the angles.
Okay, then sir, another question. For example, cos was positive. Why didn't you just find in the quadrant where cos is positive?
That's what we did. So for this one, or in the first quadrant, I mean in the previous question. Hello?
Yes, in the previous question.
So here we only got, for the positive cos, we had 60 and 300. And we are done in terms of quadrants. But what brought in so many angles was the fact that the x is being multiplied by 3. So we could get the coterminal angles of these two and divide them by 3 and still get between 0 to 2 pi.
Oh, okay.
If it was plus or minus half, we are going to have about 16 solutions. Okay, let's look for another one before we are dead. C cos 2x is equal to sine squared x. Solution. We know cos 2x is a double angle, which is the same as cos squared x minus sine squared x is equal to sine squared x. Now, whenever you have a combination of sine, cos, look, if we change sine to cos, we'll have a lot of work to do because you have to change both signs. But there's no harm. We can say cos squared that minus 2 sine squared x is equal to 0. You can choose to change n. Okay. So let's change cos to 1 minus sine squared, and then minus 2 sine squared is equal to 0. Do the addition, we'll have 3 sine squared x is equal to 0. Take one the other side, we'll have negative 3 sine squared x is equal to negative 1. Divide by negative 3, divide by negative 3. So we'll have sine squared x is equal to positive 1 over 3. Square root. So you would get sine x is equal to plus or minus 1 over root 3. So again, we have two situations here. Sine x is 1 over root 3, or sine x is negative 1 over root 3. So which positive angle gives us sine is equal to 1 over root 3? Do we have such?
No, sir.
We don't have, is it? So if we don't have, then x is sine inverse 1 over root 3, or x is sine inverse negative 1 over root 3. We end there. Because these questions will be without a calculator. So they only make sense if They only make sense if we have special angles related to the values obtained. No special angles, then make sense. Another example, D. Sine squared x plus 3 sine x plus 1 is equal to 0. So let's see if it will make sense. The first thing you do is you let any variable be sine x so that you deal with a quadratic. Is equal to 0. And then from there, you look for the factors. So the factors will be, so I intended to put a 2 here so that it makes sense. So the factors will be 2 and 1. So we'll have plus p plus 2p plus 2 is equal to 0. And then we'll have p plus 1 plus 2 p plus 1 is equal to 0. So we'll have p plus 2 and p plus 1 is equal to 0. So p is negative 2 or p is equal to negative 1. So sine x is equal to negative 2 or sine x is equal to negative 1. Now you understand that this one does not make sense. So we forget about it. And then this one, where is sine negative? X is equal to, you saw when you're doing the graphs, x is equal to 270. Change it to radians, you get 3 pi over 2. We only have one solution.
So what about if you had one as a constant?
Sine x is equal to 1.
No, the equation, the constants wherever is 2, you put 1.
We'd go for the quadratic formula, so I'm not so sure if what would come out there is going to be sensible. So I was just avoiding the undefined situation. Hello?
Yes, sir. To do this question, I've got a question here. It looks very nice. On the same.
Okay, good. It will be our E.
But don't make it 2 cos squared x minus root 3 cos x is equals to 0.
Is equal to 0. For x
For the
ranging from where to where?
they give for x is 0, let's say equal to x, let's say
I need to request downward. Uh-huh.
equal to 360
Let's equal to
degrees.
360. Okay. So you
360.
always check the interval. So if it comes in this form, our answer must be given in degrees. So now I'm answering the question of how do I know that my answer now should be in radians or in degrees? You look at the interval given. Okay, so we start. The first thing you do is you factor out the common thing. So cos is common. So factor out cos x. We remain with 2 cos x minus root 3 is equal to 0. This means that either cos x is 0 or 2 cos x minus root 3 is 0. So cos x is 0 at 90 and 270. The other one, cos x is equal to 3 over 2. Which value of x gives us root 3 over 2? Excuse. X is equal to 30, is it?
Yes.
But cos is positive in the fourth quadrant also. So what is 30 in the fourth quadrant? It is 330.
330.
We're done.
I'm
Edward,
happy,
any
sir.
question?
I'm very happy, sir.
Okay. So the key thing is
Another one, sir.
okay before. So the key thing is for me to know whether I should change to degrees or radians, I'll always pay attention to the interval they need me to find the values of x. If they give the interval in degrees, I'll present my answer in degrees. If they give the interval in radians and they present the answer in degrees, you get their marks depending on the mood of the marker. Put that in mind. The mood this year will be okay.
Yes, sir. Good
Wow.
bad. They will be okay.
But sir, yeah, if you go to this topic, can you try like on the graphs, like I have some like questions. The next, as when you will be free, like on those like makeups.
You have questions on the graphs.
Yes, sir.
Yeah, you should forward them. You should forward them. If we can,
Okay.
yeah, we will do them.
All right.
Yes, sir.
Okay,
Should
another
I give
question on
out
equations?
Yes, sir. There are two.
Yeah, you're free.
Okay.
So give
The
one.
first one is
Now give us the second one.
cos squared x minus sin x minus 1 is equals to 0.
Interval.
for the interval if x,
x if 0 less or equal to x less or equal to 2 pi.
So now we know our solution will be in radians. So whenever you have a combination of sine and cos squared, or cos and sine squared. You go to the squared one and change it to the non-squared one. Using the most important identity. So cos squared is going to be 1 minus sine squared. And then we have minus sine minus 1 is equal to 0. But 1 minus 1 is 0, so we remain with negative sine squared x minus sine x is equal to 0. Factor out sine x, you have negative sine x minus 1 is equal to 0. So we have sine x is 0, or sine x is equal to negative 1. Now when is sine 0? Sine is 0 at 0, also at pi, and at 2 pi. 0, 180, and 360. Negative 1 at 270, 3 pi over 2. Give us the last one.
No, it's exercise, this one. I want to test myself.
All right. Okay, so this is how you solve equations. Now, identities are too many, we cannot exhaust everything. Equations are so many, we cannot exhaust all of them. So we have ideas of how to solve equations, how to solve.
So let's say if sine 0 the way it is, so you have to find all the sign where it gives 0. Like
Yes,
in the
within the given interval.
all right.
The interval is very, very important. Okay. Wait before you go. There's another one. Found it. Yes. There's another one. Where is it? First, it's question 3. Prove the identity. So this is one question. 3.1. Prove prove sine 3x is equal to 3 sine x minus 4 sine 3x. 2. Hence, solve 3 sine x minus 4 sine 3x is equal to half. For 0 less or equal to x less or equal to 2 pi. It's connected. So we'll start from 1. We take the left hand side, sine 3x is the same as, 3 is the same as 2 plus 1. But we're able to expand this as sine 2x cos x plus sine x cos 2x. is it? If you look at what we are given here, no double angle, no double angle. So you change this to sine x plus x. I'm being slow here because we already have an identity of the double angle for sine, but I put as if we don't know what it is. Cos x plus sine x cos x plus x. So when you expand this, you get 2 sine x cos x. Then there's this cos x plus sine x. When you expand this, you get cos squared x minus sine squared x. But this is cos squared x. Then we change it to sine to be 1 minus sine squared x plus sine x. We change this to sine 1 minus sine squared x minus sine squared x. You expand, we have 2 sine x minus 2 sine 3x plus sine x minus, this is 2, so you get 2 sine 3x. And then 2 plus 1 will get 3 sine x minus 4 sine 3x, the right hand side. We have proved.
So I
So
have
when
a
I was
question. Where did that cos x come from? There were written 2 sine x cos x cos x.
So we have sine x plus x given as sine x cos x plus cos x sine x. So since they're the same, if we add them, we'll have 2 sine x cos x. That's where this came from. Then we had the cos x multiplying. So we have another cos x. Is it okay?
Yes, I've understood.
Okay. Then part 2, it's saying hence. In mathematics, when you see the word hence after a question, it means that from what you are from doing, continue. Use it to solve this given question. So use this fact to solve this one. So since we have said that this piece here is equal to this piece, to solve this question, you say part 2. So you say part 2, we are solving 3 sine x minus 4 sine cube x is equal to half. If you take it just like this, then you can sweat. But we know that this guy is the same as sine 3x. So we just say sine 3x is the same as half. Then let a be equal to 3x. So now you have sine a is equal to half. which A give us half for sine in the first quadrant, 30. Where else is sine positive? In the second quadrant. And 30 is 150 in the second quadrant. But look at the interval from 0 to 2 pi. And it's being multiplied by 3. So we can get the coterminal angles because of the 3 present. So we are dealing with 30. So if we go around, get there, 30 plus 360, we have A is equal to 390. Divide by 3, maybe we can bring another one. 390 plus 360, we have 390 plus 360. We'll get 0, 5, carry 1, 6, 7, 750.
Sorry, sir, what does the 3 have to do with anything?
So the 3 is multiplying the x. So it means that instead of saying double angle, we're saying it's a triple angle.
Okay.
So what does it do with anything? For you to obtain half, you can't just say x is equal to 30 because you have to multiply that 30 by 3. So if you go with 30 as your x, you are dealing with 90. That's why we're able to get the coterminals, because we'll break them down by 3. So I think this is enough for 30. Now let's go to 150. 150 from here, 150. If we went round, would say 150 plus 360. We'll obtain 0, 1, 510. So A is 510. Let's try another one. 510 plus 360. We'll get 0, 7, 8. So I have another value of A. A is 870. The other one will be beyond. So now 3x is equal to 30. So x is 10. 3x is equal to 150. So x is 50. Yes. 3x is equal to 390. So x is 130. 3x is equal to 750. Divide by 3, divide by 3. X is equal to 250. And 3x is equal to 510 by 3 by 3. X is equal to 170. Then 3x is equal to 870 by 3 by 3. X is equal to 2 in 27, it is 9, 290. And then convert them to radians. This guy is given radians. Yes. Convert them to radians. So by pi over 180, we get 5 pi over 9. by pi over 180, we'll get 5 pi over 18. By pi over 180, we'll get 13 pi over 18. By pi over 180, we get 25 pi over 18.
But sir, 10 can go into 180.
How many times?
18.
Makes sense. But how come 5 pi over 9 is not going there? Oh, it's actually wrong. No. This one is wrong. So it's supposed to be pi over 18 because you need to cancel the 0. Okay. What about 170? By pi over 180, we'll get x is equal to 17 pi over 18. And then here, by pi over 180, we'll get x is equal to 29 pi over 18. So present 1, 2, 3, 4, 5. Lucky enough for the guys who wrote 1120, I was given the task of making the marking kit. So I realized that the solutions in most questions, in most papers, you guys could only give one solution, maybe pi over 18 or 5 pi over 18. So to avoid complicating people's lives, we just said any two solutions will give full marks. That was maybe in good moods, not knowing about other moods.
So, sir,
I'm asking for the previous screen.
And this question was nice because you can fail part 1 and still get part 2 correct. As long as you understand the question. And part 2 had more marks than part 1.
Sir, so in cases where x is not being multiplied by any number, we don't need to use the coterminal angles.
No,
Okay.
no need. Trig identities. And equations. Okay. Have a good night.
Sir, before you go,
Mm-hmm.
there was that question, cos 2x is equals to sine squared x.
Cos 2x is equal to sine squared x.
Yes, that one. After finding cos squared x is equals to cos squared x minus sine squared x is equals to sine squared x. Then you move. What if you move? You move sine to the other side. It becomes cos squared x is equals to 2 sine squared x. Then you find tan.
Then you find?
You find 2 tan squared x is equals to 1. So that tan squared x is equals to 1 over 2.
which is equals to, which will give you tan squared, tan x is equals to 1 over square root of 2. Then you find the angles.
1 over root 2 for tan.
Yes.
Do you have special angles for tan? No.
Okay.
That's why we suspended it like that.
Okay, sir.
All right, sir. Stop recording.
Okay.
So how is the mood, sir?
Mood is happy.
It's nice. You won. Finally.
Finally.
Everyone felt okay.
Very much.
Yeah, to retire without being a president would have been very bad.
So now we'll see what happens on Tuesday. Kai the last statement that Mureko Tika.
Again, just help the man. And
No,
just
but does it started happening, Kairi?
yes, it's happening. You will manage the economy.
The guy who managed this like is very, very serious.
Infrastructure is already there, so I just have to fix
Yeah,
it.
so him is just going for the economy.
It will be nice.
Yeah.
It will be America. That's what he said.
We can't wait.
All right, so good night.
Good night.